and I will come to you. What is the meaning of MTU? We have a simple diagram here. We have host A here. And by the way, if we are talking about MTU, don't think that we are deviating from the course. Nope. MTU is one of the important considerations while we are going to develop VXLAN underlay. Okay. So we have host A here, we have switch here, we have router here, and we have another host here. Although you don't see that host is directly connected to the router, but I do not want to take more space in putting one more switch, so I directly connected it, right? So use your experience that, okay, if it is fine, if I'm connecting it directly, but generally you do not see the host connected to router directly. There must be a switch in between, right? Now, what I've done here is I have shown all the TCP/IP layers when we talk about A, which is the host, which is the computer. When we talk about switch, I am showcasing you only two layers, layer 2 and layer 1. In case of router, I'm showcasing you layer 3, layer 2, layer 1. And again, here I am showcasing you all the layers. But why? You all know switch understands only layer 2. If I'm talking about the switch, only switch functionality, and here is the problem, guys. Switching starts or the routing start in 1970s, and we are into 2023. Where should I start, right? Most of the people say switch is a layer 2 device. What is the meaning of it? It can understand layer 2. But if I talk about switches in 2023, they understand everything. They understand application layer, transport layer, network layer, everything. Believe me. If you talk about router, today's router understand not till layer 3. They understand till layer 7, right? But layer 7, or basically you can say application layer. But believe me, if we talk about the core working of a switch works on layer 2, right? If I say switch is the layer 2 device, it means that it can understand layer 2 as well as layer 1. If I say router is a layer 3 device, it understands layer 3, layer 2, and layer 1, right? Because when a mesh packet comes to it, it sees the destination MAC address. If it is for it, it is going to open it and then move towards network layer and sees the destination IP address and forward it, right? These are very, very important things. These are the fundamentals. And now suppose host A wants to communicate to host B here, and host A wants to send a file which is 10 MB long, and the file name is file1.txt, suppose, right? And this file, they want to transfer it over a protocol which is FTP, and they are using FTP application for that. This is a simple file transfer application which can transfer your file. But can we send the 10 MB file as it is without doing any change in it? Believe me, you cannot do that. You have to break this 10 MB file into multiple pieces. So you are going to get 10 MB of data from the application to transport layer, and transport layer will be segmenting it, or it will be breaking it down. It will break it down, right? And these segments are known as, and these little pieces are known as segments. And that is why the unit of data at transport layer is segment. But here is my question. What should be the size of this segment? Very, very interesting. I have a 10 MB file. I want to break it to multiple pieces so that it can go. First question arise. Why can't I send the 10 MB as it is? And here is the point. The problem or the point is that here we have the Ethernet interface, and the maximum data, the maximum payload, my Ethernet can take is 1500 bytes. Again, it all depends on history. Why the default or the maximum size can go over Ethernet is 1500 byte is because this is developed around 1970s and 80s. Guys, there were no data at that point. Means data was there, but it was not huge, right? 1500 byte is too much, but in today's environment, 1500 byte is not that too much. You all know about it, right? But what we can do, if you go and check your laptop interface, the Ethernet, the default size, the maximum size is configured there, which is 1500 byte. And at once, one packet cannot take more than 1500 bytes of data. And basically, this 1500 bytes, which is you have configured as a default value on Ethernet, which is the maximum value that can go over Ethernet, is known as maximum transmission unit, MTU. As simple as that. Now the question arises, we all know that if I get this segment from here, segment number 1, right? Network layer is going to put its header, which we call the L3 header or IP header, source IP, destination IP, QS information, offset, so many information is going to be there, right? And if you do not know, I would like to tell you this, the length of this layer 3 header is 20 bytes if we do not consider options field. Why I am specifying the options field? Because it matters in many cases, but generally we do not see the options field. So I am taking the default value that generally if we do not have options, then we have 20 bytes, right? Somewhere, sometime I will be discussing options too, but not now. Now, when this message moved to from, sorry for this, yeah. Uh, one moment, guys. I need to rub this so that I can explain you well. So here I have this file of 50 MB, right? Application layer is giving it to transport, and transport layer is basically giving them distributing into some segments, right? Segment number 1, segment number 2, and so on. So suppose transport layer decided to send this segment number 1. First thing first, right? What is going to do? It is going to put its own header on top of it, which is known as layer 4 header, right? Which is going to have source port, destination port, sequence number, acknowledgement, and so on. If you calculate this, this is going to be your 20 bytes. The same thing. As I mentioned, in case of network layer, IP header size is also 20 bytes, and I'm not considering the options field. By the way, transport header or layer 4 header and IP header both have option field in certain situations, but I'm not considering them. If that is the case, 20 byte is the layer 4 header size, right? What is going to happen when transport layer give this to network layer? We will be seeing this message. First thing first, S1 means the segment. Then we are going to see the layer 4, which is of 20 bytes. And then we are going to see layer 3, which will be again 20 bytes. So the segment plus 20 means 40 bytes, right? Now, when we reach to data link layer, you have specified on Ethernet that Ethernet cannot take data from more than 1500. Very, very interesting, right? And what data link layer gets? Data link layer gets this data from network layer, which is having S1, which is the segment or the data, actual data, which is going to have this L2, which is going to have this L3, and this will be getting by this data link layer. Believe me, data link layer can take only 1500 size of data, 1500 bytes of data. It means that when data link layer receives it, it is going to put source or L2 header. For data link layer, what actually this is data, whatever it is coming, maybe it is coming from network layer, ICMP, TCP, or whatever, right? And I am saying that data link layer can take only 1500 bytes of data. It means that if you sum it, it should not be more than 1500 bytes. If it is more than 1500 byte, it is a problem because Ethernet can take only 1500 bytes of data. It's as simple as that, right? Very, very interesting. If it is less than this, no problem. But if it is more than that, it's a big issue. We need to fragment the packet. We need to divide the packet into multiple portions, right? But if it is 1500 byte, that is not a problem. So what is going to happen? We have, if I say, now can you calculate what should be the size of this segment number one? Or what should be the maximum size of this segment? You can easily calculate. Why? The total length should be how much? 1500, right? I want to calculate the size of this segment. It means that the size of this segment can be calculated if I minus 20 of TCP header or layer 4 header, and if I minus 20 of network layer, then it is going to be 1460. The maximum segment size, right, of a segment which is created by this transport layer is going to be 1460, because we all know that when we need to add TCP header on top of it, which is 20 bytes, and we need to add IP header on top of it, which is 20 bytes, it is going to make it 1500, and then this 1500 can go over this Ethernet. As simple as that. Guys, if any point of time you see a confusion, just let me know. Now, the question arises, really the 1500 bytes are going on? No, 1500 is the amount of data which can go on it. It means that if we consider the layer 2 frame also, layer 2 frame is 14 bytes long. How come? In layer 2 frame, you are going to have source MAC, which is of 6 byte, destination MAC, which is of 6 byte, and the type field, which is of 2 byte. It means that generally 1514 bytes of data is traveling over this interface. Do not get confused that this interface can take 1500 bytes of data. No, this interface can carry 1500 bytes of data or IP information or whatever it is receiving from the network layer. But yes, this interface can have more data of the layer 2, which is source MAC, destination MAC, and type field. And of course, if you are aware of the layer 2 header, you all must be knowing that once layer 2 is injected or layer 2 header is put in, we put layer 2 header by layer, if data link layer put layer 2 header, it put the trailer also, which is known as FCS, which is frame check sequence of 4 byte. It means that the actual data which can flow on this is 1500 byte of MTU plus 18 bytes of trailer and header information, 14 plus 4. So this is the normal size, 1518. If it is going over this Ethernet interface, that is perfectly fine, no doubt about it. But now you can ask me, Mr. Vishnu, you are okay. If we are talking about this host and switch, there is no doubt about it that you are absolutely right. This is the standard frame size. This is not the MTU. 1518 is not the MTU. MTU value is 1500, but the frame is of 1518 bytes because we have added data link layer to it or data link header to it. As simple as that, right? Now, let's talk about when this switch Suppose another switch is here, and this is switch is sending the message of VLAN 10. Then you must be knowing that this frame or the layer 2 header contains extra field which is known as .1q, which is of 4 byte in length. Interesting. When you were in our switching classes, I have explained this Ethernet header into detail, right? And if we see that 4 bytes of .1q header, if we add it somewhere here, then we are adding 4 more bytes. It means that if we add 4 byte of .1q, it is going to give us result 1522, right? I am again defining 1500 is for what? 1500 is the MTU value, whatever the Ethernet gets from the IP. Then 20 bytes is, then 14 byte of Ethernet header plus 4 byte of .1q plus 4 byte of FCS. If you add them, it is going to give you 1522. This is absolutely normal. All the devices, switches, router understand this much. But if you send information more than 1522 over this Ethernet is going to definitely complain. And suppose you want to send a message of maybe 2000 bytes. Interesting. Over this, then what you need to do is you need to divide this message into multiple parts, and this division process is known as fragmentation. If there is a message which is more than 1522, or if this host is sending a message, or if it is a MSS which is 1460, and because of some misconfiguration this host is creating a message of maybe 2000 bytes, it's a problem. When it reaches to network layer, data link layer will be crying, right? I cannot take more than 1500 and you are giving me more than 1500. At that point of time, you need to fragment the packet. Try to understand from all this discussion. See, if you understand this thing now, or maybe previously also, now we are on the same page. With this knowledge, we can understand the GRE overhead and GRE MTU and what is the problem it is going to create. Okay. Although there were so many questions on this thing, right? Some people ask me that, Vishnu, is there any relationship between MSS, maximum segment size, and MTU? And I explained them, yes. So I am asking question and explaining. Guys, if you have any question from your previous experience or something, please do ask. Otherwise, I am going to answer this question for sure because this is the problem for many people, right? So MSS, or the maximum segment size, is the concept of transport layer, or specifically if I ask a TCP layer, right? Here, it comes here. So what exactly happens? Suppose host A wants to communicate to host B here, right? And suppose they are doing FTP, and you all know to transfer file over FTP, we need to make, first thing first, a connection, right? And that connection is a TCP connection, and TCP connection we can make through three-way handshake. In this three-way handshake, what is going to happen? Source A is going to send a SYN message. It simply says that I am sending you a message with this number, with this sequence number, right? And B is going to say, okay, I acknowledge it from here to here. And it says, because there are two streams in TCP, one from source to destination, one is destination to source. And it also says that I am also sending my SYN message, means I will be starting from this sequence number. And then your A will be saying, okay, perfectly fine, I will be acknowledging it. So these are the three steps, 1, 2, 3, and we call it a three-way handshake. But believe me, there is one more interesting thing happens when this three-way handshake happens, right? Host A says, when it makes the SYN connection, host A is pretty intelligent and it knows that its data link layer, the MTU configured is 1500, right? So in this SYN message is it informs the receiver or host B that its maximum segment size is going to be 1460. And how it must have calculated? It sees that 1500 is the default MTU configured, right? And if I minus 20 byte of IP and if I minus 20 byte of TCP header, it is going to give me 1460. Please remember, if this value you configured is 1400, then it must have configured or send this MSS value as 1360. Why? Because now the maximum transmission value or unit is 1400. We need to subtract IP header and TCP header from it, right? So it depends. This MSS value is calculated on the basis of what you have configured at Ethernet. What is the maximum transmission unit of that Ethernet? Really interesting, right? And then the B says, okay, I do agree with you that you want to send the 1460 MSS value. And here I can see that I have also configured the 1500 MTU. And when it sends its SYN message, it is going to say my MSS value is 1460. Both agrees on it. But it might be possible that somebody has configured a MTU value of 1200 here. So this guy says that, okay, you are sending a 1460 to me, but believe me, I can send only 1200 to you, right? Or maybe 1160 if I minus those. So they select the lowest one so that packet do not need to be fragmented. So this is the relationship between MSS, which is a concept of layer 4, and MTU, which you define at layer 2. What is the maximum value you can carry, right? People have asked so many questions, and I encourage you, if you ask question, then it is going to be great. And I can see that there is a hand raised for Mr. Prakash. Prakash ji, please do ask your question. Please go ahead.
So, the actual hardware interface also we are setting MTU, and the tunnel interface also we are setting MTU.
We will come to that. Do
Yeah,
not worry,
okay.
Mr. Prakash. What is the impact of configuring IPMTU on tunnel and on actual hardware? I will be letting you know, right? Don't worry. It is coming in the next board, Mr. Prakash. Now we have a question from Mr. Supreet also. Supreet ji, please ask your question.
Vishnu, thank you. So this might sound a little funny,
Hmm.
but the MSS gets exchanged initially in the three-way TCP handshake itself, right?
Yeah.
So it pre-configures itself to 1460 size because it only measures the payload that is there. It doesn't measure the TCP header and the IP header, which is 2020 bytes. Correct?
It is see, I am saying that it depends on whatever you have configured at whatever is the system value or the MTU value of this system of this host. The MSS is going to be calculated on the basis of that. If you have 1500, then it will be 1460. If you minus those, if this is 1400, that is going to be 1360. Mr. Supreet.
Yep, got it. Thank you.
Perfect. Mr. Vishnu, please do ask your question. Please go ahead.
Yeah, Vishnu sir, this is a TCP session formed between source machine and the destination machine.
You are right.
Correct?
Right.
Now, what if an interim device is having a different MTU? So how would these machines negotiate with that and get the least MTU value?
That is what I wanted to hear. See, basically, this is a fantastic question, right? And there are multiple solutions of that. For example, suppose I have this host here, host number A, I have host number B here, and it could be the case that there are multiple routers or switches in middle, right? R1, R2, R3, R4, and then basically we have connectivity like this. They are making the TCP connection and we very happily, and they have negotiated an MSS value of 1460. presuming that this interface value MTU is 1500. We all agree that till this point, that is fine. But now, what has happened here? That on this router R2, somebody has configured or changed the default MTU value from 1500 to say 1000. Say, it could be possible, right? If that is the case, what is going to happen? This host A and B are totally oblivion from the fact that somebody is in the middle who is actually doesn't have this 1500 MTU, right? It is having only 1000 byte of MTU. What is going to happen? Let's create a packet. We will be sending this data, right, into an IP packet. The data is going to be, let's make this complete message. We will be having a data which is coming from TCP, and suppose that this data is 1460. Then what we are going to do, we are going to add layer 4, we are going to add layer 3, 20, 20, right? And of course, this can be going inside a Ethernet where you are going to put source MAC and destination MAC. There is no doubt about it, right? But the important piece is this is the data which can be carried in the Ethernet frame, which is of 1500 byte. The message can be moved from here to here. There is no doubt about it. It will be reaching here. Outer source MAC destination will be gone, and the 1500 byte message is going to be here. There is no change. By default, everything is 1500. So it is going to send again this message with different source and destination MAC. It will reach to R2. Now R2 has to decide that to send this packet towards B, I need to forward it to an interface which is 0/1. And here, unfortunately, the MTU value is 1000. It means that I cannot send this 1500, right? So what will happen in this case? This data plus L4 plus L3, right? This is from here to here is 1500, right? What is going to happen? I have to fragment this message here. R2 has to fragment this message here. So first thing first, it is going to check whether this do not fragment bit is enabled or not. If do not fragment bit is enabled on this IP packet, so basically inside the IP packet, there is a field which is known as DN or do not fragmentation bit. If it is set, no router can fragment it. Okay, and this can be done by this host when it has created this packet. It can set the don't fragment value, do not fragment value as 1. If that is the case, nobody can be going to segment this packet or divide this packet, right? But now I am presuming that do not fragment bit is 0. It means that anybody can fragment this packet or divide this packet, and now this is the responsibility of R2. What R2 is going to do? R2 will be saying, okay, from here to here I have only 40 bytes, and from here to here I have 1460 bytes, right? Right. So I will be taking 1000 bytes here, means 40 from here, right, and 940 from here. Okay, and the remaining bits will be here. So this will be my first packet. Of course, layer 4, layer 3 is there, and now this the data packet. I will take it. The remaining 940, if you subtract, then it is going to be 640, I believe, right? Or let's calculate, right? We have 940, then 60 is going to be 1000 plus 14,460. So you can say 1400 and just wait a minute. I am just doing the wrong calculation, guys. See, what I'm doing is I just want to divide it, right? We have 40 bytes here, layer 3 and layer 4. I want to have 960 more bytes so that I can send 1000 bytes. As simple as that. So after 1500, if I have removed these 1000, right? So how many I am getting? Only 500. So here is the data, which is 500 bytes. And now I need to put source MAC, sorry, layer 4 header and then layer 3 header on top of it, the same one. So now the one packet which I had is divided into two different packets, right? One is from here to here. This is packet number 1 and this is packet number 2. Now from R2 there will be moving there are going to be two packets which will be going out, packet number 1 and packet number 2. While doing it, it sets the fragmentation offset. If you do not know about that, that is perfectly fine. But if R2 has divided this message, it leaves some traces of it, that this packet is not the final one. Mr. B, when you receive this packet, one, just wait for the other fragment of it. Once the second is reached, 1 plus 2, you can add them or you can reassemble them, and your packet is going to be complete at the B, right? This is what happens when we have this, right? But one interesting thing happens when R2 fragment this is send the message back, right? And this is the ICMP message which informs host A that your packet has been fragmented. It means that host A come to know, okay, if my packet is fragmented, then my entire path is not able to take the 1500 byte message, and that is where it is going to, just wait a minute guys. Are you perfect? Perfect. So I was just saying the ICMP message was there from R2 towards A, where it come to know that basically my message is fragmented. So this time it will try to reduce it from 1500 to maybe 1400, and if it gets continuously ICMP fragmentation message, it is going to reduce the size. And this is known as IP path MTU discovery, right? It is not the case that it is going to happen, but when your network says that your packet is fragmented, then basically it happens. But believe me, most of the time in a network you have firewall, and firewall generally do not respond for the ICMP message. And suppose if a firewall is fragmented your message, it is not going to send ICMP. If that is the case, this host A would never come to know that its messages are fragmented. So believe me, this, I'm not saying your communication is not going to be there. Fragmentation, if the packet is fragmented, it doesn't mean that the communication is not there. Communication will be there. But this router has to work extra. Apart from its normal routing, it is fragmenting the packet. And if it is fragmenting the packet, it's a problem. Right? As simple as that. Anybody?
Vishnu sir, if I ask some follow-up questions as well. So now instead of
Vishnuji, if I may stop you here, if you can ask this question at the end of the class, it is going to be great. Otherwise, we will totally derail from the topic. But yes, sure. I do agree with you. If I explain only MTU and MSS in greater detail, it is going to take 2 hours for me. Believe me. But that is fine. If you, we will be here after the class and we will be discussing it. It might be the case that the number calculation might be wrong little bit, but that is fine, right? You can easily calculate these numbers. Let's go and talk to MTU considerations now, right? Although we have discussed here, but now I will, maybe you will get your answer, Vishnu, here also, right? Now, what is happening here? This is the normal diagram which is under our consideration from last 2 classes, right? Last class also. So we have GRE tunnel here, and now see what's happening here. So we have this Delhi branch, we have this Bangalore branch, and Delhi branch host number A wants to communicate to host number B. What it's going to do? It is going to send a ping message or ICMP, right? It is going to say ping host B, which is 10.10.20.20 here. So what is going to happen? It is going to create the ICMP message. And I am assuming here, because this is not created at application layer. This is only created at the layer 3 layer, layer 3 level or layer 3 layer, right? L3 or the network layer. So I am presuming, suppose this is the 1480 byte of data, and on top of it you have placed IP, which is 20 bytes of data. Source is 20.20. So destination is 20.20 and source is 10.10. Now what is going to happen? This is your entire 1500 bytes of information which can be carried. But now the problem is we need to put some more information. We are putting this GRE information, and you know all why? Because GRE will inform that there is another IP packet inside. GRE has a protocol field, which we have explained yesterday also. And now this packet is encapsulated in another IP packet, which is again 20 byte long. The 20 byte here plus 4 byte here, we are adding actually 20 plus 4 bytes of data means 24 bytes, right? If you calculate entire thing from here to here, 1500 were previously, then 4 byte of GRE, then 20 byte of IP, you are going to get 1524. Guys, the packet will be going out from this interface, 0/1 interface. If that is the case, right, the maximum MTU is 1500. If you want to send it over this interface, of course, you need to put source MAC and destination MAC, which is 14 more bytes, right? But Ethernet says that you can carry only 1500 bytes of data. But my problem is this complete packet from here to here is actually your 1524 without Ethernet header. You cannot take it. Very, very interesting, right? If that is the case, you need to fragment this message, which I have explained you previously also, right? What is going to happen? You all know that from here to here, this information is 24 byte, right? And here this is 20 byte. And then we have 1480 byte of this thing. So we will be fragmented. So maybe this packet will be broken down from here, because we can take 1500. So wherever the sum is becoming 1500, we will take, of course, the 24 byte will be remaining here in the data field, right? So this packet is going to be your packet number 1. The second packet is going to be this fragmented packet. Only 24 bytes of information is there in this data. And then it needs to go to where? Source IP is going to be 20.20, destination is 20.20, source is going to be 10.10. Again, you need to put GRE header on it. It should go from 1.1.1 as source towards 2.2.2 as destination. Very, very interesting, right? Now, there are two packets which is coming out from this interface. One is packet number 1, entirely this one. Packet number 1, packet number 2, which is having this 24 byte of overhead to send to 24 byte of information. Really, really interesting, right? Wow. So as I mentioned that we need to fragment the packet in this case, right? And here we can configure on this physical interface or this interface. We can configure IP MTU is equal to, instead of configuring it to 1500, I can configure it to 1500 minus 24, right? then what is going to happen? It will be resulting into 1476. So IP MTU, I can mark it 1476 here, right? Or I can write IP MTU as 1476 here. But still, if my data is more, I need to fragment the packet. Now I can see Mr. Burak has raised his hand. Mr. Burak, please do ask your question.
Okay, thank you, Vishnu. Why don't we enable the jumbo frame on the interfaces on all the devices?
Yeah,
And the mission is done. Why
absolutely.
don't we use this
Absolutely.
option?
You are absolutely correct, Mr. Burak. But try to understand, we are talking about GRE. GRE is an old protocol, right? Very old protocol. At that moment of time, these devices, the switches and routers were not capable enough of sending more than 1500 bytes of information. Believe me.
Mm-hmm.
But as we move, now we are in 2023. Believe me, your Nexus device can carry data. This default 1500 byte is changed from 1500 byte to 9000 bytes. Any packet can move, right? But still, your internet is still working on those old devices which do not have this capability to increase the MTU value of Ethernet from 1500 to something more. This is the only reason. Okay. But
Yes.
I would like to explain the same thing, that how we are solving this problem in 2023. I am just telling about nitty-gritties of MTUs and all. The solution is very, very simple. If we can increase this MTU value from 1500 to more than this, then there is no doubt about it that the problem is solved. And we will be solving this problem in case of VXLAN. And that is where I am moving to the next book.